Everyone, welcome to today's Snack and Learn webinar. This is actually our last Snack and Learn webinar for the year. Happy to have everyone today on the call. Just mentioning the housekeeping items briefly. The presentation slides are available to download in the handout box in the control panel. And also there will be time for question and answers. If you can please log your questions in the question box. I will hand it over to Jaco to start the presentation. Thank you.
Good morning, good afternoon, good evening, everyone. Thank you so much for joining in and dialing into today's session. It's a privilege for me to be able to speak to all of you. We really have a great group of people on the session today from across the world. The intent of today's session is to speak about how do we develop an engineerable digital healthcare vision. It's sometimes easy to set a vision, but how do we translate that into an engineerable aspect? My name is Jaco Cronje. I'm from WSP, based in Houston, Texas. We're going to use a case study today to talk through how we would go about developing that engineerable vision. We will be looking at what are the trends that we see within the future of healthcare. You would also hear a lot of buzzwords in the context of smart hospitals, future healthcare, digital healthcare. So when we speak about things like smart buildings, IoT, of Internet of Everything, what do those terms really mean? And how can we integrate the buildings that we design and we construct and we operate in such a way that the control systems within them can provide additional insights rather than only providing controls of their respective subsystems? We are using a digital design approach. So as we speak through and as I reference some of the examples in today's session, it really is thinking around how do we develop that digital, that engineerable vision and translate it down to aspects that our different design teams can together build on. By the end of today's session, we'll have a recap at the end, but you should be able to articulate the concept of integrated building technologies and an integrated building technology platform. Consider what opportunities may exist at your facility or in your project to enhance patient experiences, their loved ones or experience with their loved ones, the caregiver experience, and also how to optimize operations for the facility itself, for the FM team, for the engineering teams, and for the executives of the facility. And then finally, a basic understanding of when technology should be considered within the master plan process. As I mentioned, Jaco Cronje, based in Houston, an avid cyclist. We love traveling all over the US to explore different spaces and places. And while I speak today about the digital vision, I use data fairly extensively, whether that is through my Garmin watch, whether that is through WIP biometrics, whether that is Google Smart Home, where I can set up routines, I can look at data, I can draw trends from historical data. So I think point being here is that the application of data in projects is also very personal for me for the application of data in my own life. Today's overview touch on just a brief introduction about who is WSP and what do we do within the space and the realms of healthcare, because we have a public audience on the call today. What do we see as the digital trends in healthcare? Really focusing on an experience-based or an outcome-based design. We're going to be looking at a case study and then open up for some questions and answers towards the end of the session. So if we dive into just an introduction of WSP, 73,000 and growing employees all around the world. It is an amazing firm to work with opportunities really all over and projects in every possible sector. We are a engineering consultancy. We've been ranked #1 in ENR's list of top design firms. And if we think more specifically around the healthcare space, we've designed over 60 million square feet of healthcare projects in the last 7 years, and ranked #2 in as the top healthcare engineering firm last year in 2023. Within our properties and buildings division that I form part of, the outcomes-based design that I mentioned earlier can take on some of these pillars, some of these 7 pillars that we have on the screen here. specifically market innovation, so just touching on them briefly, looks at developing strategies for our clients across a wide variety of sectors. Our integrated design teams coordinate various engineering disciplines and ensure that we deliver a holistic product across our design teams. Building systems are the SMEs in their respective focus areas. High performance design tied closely to building optimization looks at enhanced commissioning, looks at operational efficiency, looks at alternate methods of construction and how to incorporate different types of materials to increase the operational efficiency and also reduce the carbon footprint of our properties, or the properties that we design. The trends that we see in healthcare, I've listed on the screen. There are admittedly many more trends, but we do see these bubbling up to the top in various conversations that we have all across the world. So this is not just the trends we see in the US, but also when we look at it from a global perspective. There's a major focus on the patient. That is at the center of any healthcare facility, focusing on the patient and their loved ones. We see that there is a significant revolution in methods of treatment, and I'll speak about that in a couple of slides' time. But how do we design facilities now such that they can be flexible to adopt methods of care? A big drive around resource efficiency, shortages of engineering teams to manage facilities, shortage of caregivers, costs of resources, and then trying to be as efficient as possible with our energy, gas, water, etc. consumption. In order to achieve these outcomes, informed decision making becomes a key aspect. So using data and leveraging data from various points within the building to draw trends and enable contextual awareness. There are increased number of risks that affect healthcare facilities, whether that is cybersecurity, which we'll speak of, whether that is changes in weather patterns, whether it is global pandemics. So how do we design a facility such that it is more resilient and therefore can bounce back quicker should something have happened, or should there be an external impact to the building? When we look at these societal drivers and we look at what's happening with digital transformation and the technology enablers, the opportunity for our projects lie really at the center of those. So we've got a commoditized economy. Think of services like Uber, like Lyft. So a big focus on providing healthcare, simplifying healthcare and providing that capability to patients themselves. A decentralized form of care, and on the flip side, we have increased use of and development in robotics and AI providing optimization. So these are the forces that play out, but we can either view them as challenges or we can view them as an opportunity. When we design our facilities, we think of the now, new, next mantra. So now reflects on how do buildings operate today. New is, if we're designing a facility now, what should we be designing for? Because that technology is not legacy anymore, it should be adopted for. And next is thinking, what is going to happen 5, 10, 15 years down the line? Because a lot of these healthcare facilities have longer design periods and master planning periods. And what decisions should we be taking now to support those outcomes and those capabilities in future? So I'm going to reflect on that process of the now, new, and next. If we think of the now, it's standalone systems. If we think specifically of digital and technology, standalone control systems, a lot of those control systems run on their own dedicated networks with their own internet connections, so increased capital expenditure cost as well as operational costs for ongoing maintenance and support of those systems. If we transition to so now would be how our facility is currently operating. If we think of the new, we keep that list on the left as what was the now. How that impacts the new design as we start to look at control systems that can exchange data So control systems that use open protocols, control systems that can support a platform, a digital platform where data can be shared and enhanced decision making can be achieved. We look at convergence of networks, convergence of the copper and the fiber infrastructure, consolidating internet access through a cyber secure interface. So we're starting to get to a facility that is more integrated and a facility where we can use data really as an asset. The question really is then, what is the next? So to look at the next, or to consider the next, we need to look at what are the trends and what's happening out in the development space. So a good example is having a look at what is what's launched at CES. CES, the annual consumer electronics show, taking place every year, and it's coming up very soon again. But some of the trends that we saw in 2024, a dramatic increase in the availability of wearables, the commoditization of healthcare, so I mentioned that earlier, a lot of AI implementation, whether that is through sensors, so that's the IoT space, whether that is through real-time translation and real-time data processing capabilities. So those are some of the examples of what we see coming out in the future. And when we look at those trends, we need to bring that back to the facility itself and say, how do we design the facility differently in order to enable those outcomes? So the approach we follow there is an experience-based design approach. We look at the operational efficiency as the heart of the facility, because it needs to remain operational. And then so it can serve the patient. It needs to have adequate facilities so that caregivers can deliver what they need to do, and it needs to remain profitable and operational for the facility to have longevity. The approach we take here is to go look at the trends, both current trends as well as future trends, and go through an experience-based review with the client and with a broad group of staff members from a client body. So we involve traditional IT teams, we involve the innovation teams, we involve sustainability, operations and engineering, caregiver staff, patient experience staff, security. It's important to get holistic input from all of those teams in order to better understand how the facility can adopt to these trends and how these different trends can be implemented. So some examples that I'm illustrating here is the adoption of digital twin and how the facility can be optimized and how operations can be optimized by improved decision making, by energy analytics, by fault detection diagnostics, by leveraging data to better understand how the spaces are being used. To drive carbon goals, looking at granular utility metering, again, whether that is water, gas, energy, BTU, chilled water, etc., understanding how and where the different utilities are being used. Other trends that we look at are, and these are just a few examples that we put on the screen, autonomous wheelchairs that we've already seen deployed at Miami Airport as an example. I know that's an airport and not a healthcare facility, but it's important when we look at these trends to look at what is happening at convention centers, what is happening in airport spaces, what is happening in retail, what is happening in hotel environments, because the hospital facility really touches on various of those aspects. And if we can take lessons from those other property types, we can apply and provide a meaningful difference for caregivers, for patients, for operational staff within a healthcare building. Autonomous vehicles are increasing, electric vehicles. Many of the facilities that we design are located on a campus, so simplifying the movement of patients around the overall facility, whether that be through, for example, autonomous shuttles. What everyone has in their hand is a mobile phone. That mobile phone provides access to a variety of services. So I've used Marriott's app as an example, but really being able to track your appointment, being able to queue for next appointment, being able to understand how long the waiting times are, how to navigate through a facility. These healthcare facilities are really large, and as I mentioned, they're on a campus, so moving around between different buildings. And on the staff side, booking rooms, knowing when patients require specific services, alerts, etc. So that mobile app provides a platform for enhanced awareness. And when we consider this mobile app as a potential use case, it really starts to drive the types of data we need to collect and how the data exchanges between the different systems. So using a case study, we're looking at a new ambulatory care building that we designed here in the US. It was a significantly sized facility at about 2.5 million square feet, 300 plus beds, and WSP's role was for the design, master planning and design across a number of different engineering services. I've listed here MEP, fire, sustainability, traditional technology design, digital design, etc. We have a team of more than 25 people that worked on the project, and we partnered with 2 other engineering firms to deliver this project. Their requirements, or the requirements for an engineering digital vision, what we put out as key requirements is the fact that we need a converged network that can support the data exchange between different control systems. So those are security systems, they are traditional IT systems, communications, engineering systems, as well as patient experience and overall experience and audiovisual systems. When we look at data between all the different control systems, it is essential to tag the data because that allows you to standardize on how data is captured into a data lake, which can then be used for trending and for analytics as well as alarms. We want to make sure that we do not close the design down to any single vendor. So open protocols is key. The thinking there is to develop a mosaic of solutions, which allows the healthcare facility to in future swap out any specific system or any specific piece of software and bring in a new best of breed solution. With that approach, they can always stay on the forefront. So really when the future is unpredictable, what steps can we take to allow that flexibility, not just within the physical architecture of the building, but within the digital architecture of the building to support future products, future capabilities, and future functions. That data lake that I spoke about, or a CDE, a common data environment, provides a central location or central repository for data to be collected. It allows the healthcare facility or the client to own the data, which is critical because that data is becoming a commodity. We also followed an approach not just of collecting data for the sake of collecting data, but data was collected to drive specific key performance indicators. The digital architecture, I mentioned this earlier around flexibility to support swapping out of systems, to support different OEMs, to ensure that there's a competitive marketplace to provide solutions for this client. And then a data-driven approach to system selection. If we know, and I'll show that on the next slide, if we know what data we need, we can determine the system. The respective control system engineers can then design their systems to ensure that they have the right sensors that provide the required level of data granularity. So this data driven design process maps out what the outcomes are that we are trying to achieve based on those workshops that we've conducted with a client. Those outcomes will drive the data sets will drive the systems will then need to work around the sensors in across the facility and across different control systems. This type of mapping also allows us to better understand, as well as the project management team, the cost teams, to better understand the impact that any one system has on the outcomes of a facility. So when it gets to a value engineering stage, when it gets to a stage where prioritizing for spaces, prioritizing capabilities is considered, then we know what is the impact of any one system in order to drive that decision. Looking at the architecture of the now new Next, So the basic architecture, technology architecture followed at the moment is one where we have patients and enterprise systems. They do communicate with the cloud, and you have standalone facility control systems. The new is where these facility control systems not only feed into their platforms or DCSs, but they also feed into an overall platform. And that smart building platform communicates both with the cloud as well as enterprise systems. The question may then be, what is the next? And the next we see is that there's increased capability in AI for edge-based decision making, such that the field devices can control other systems in such a way that it automates and enhances the experience for the patients, removing requirements and overhead or repetitive tasks for the operational teams. When we follow this approach, we are inadvertently increasing the attack surface, the digital or the cyber attack surface of a facility. So cybersecurity goes hand in hand with designing that digital engineering vision. And when we go through cybersecurity, we look at the different attack vectors that can be used by an adversary. We identify where those risks and threats are, and we provide recommendations to harden the facility and increase the cyber posture of the client. So to recap, the key takeaways here from that specific project that I referenced, as well as broadly speaking from this space, is the importance of interdisciplinary project management. So as being able to share data, design data, outcomes, observations across the MEP, fire, structures, architectural, etc. teams. It's understanding that digital impacts not just your traditional technology systems, so it's not just your nurse call and your security systems, but really starts to impact metering, it starts to impact single line design, it starts to impact duct routes, equipment selection, etc. The different stakeholders are, or identifying those stakeholders and setting and understanding their key performance indicators allow us to develop those outcomes, those strategic outcomes and objectives that the different control systems must enable. So those KPIs allow for tracking, and if we can design the technology in such a way that those KPIs are easy to follow on a dashboard, it enhances the ability to do data-driven decision making. And then finally, the importance of designing from first principles. So instead of jumping to equipment and trying to find reasons for including different pieces of equipment, we look at an approach of what are we trying to achieve, what data do we need, how do we select sensors and control systems, and how do we engineer from the bottom up to enable those outcomes while ensuring that there's flexibility for adopting and adapting to future trends. With that, I'll hand back to you, Erin.
Thank you. Fantastic presentation. Just mentioning the housekeeping items again, the presentation slides are available to download in the handout box, and also please continue to log your questions in the question box. I will start with the first question. How can technology help with national nursing shortage?
That's a good question, and it's something that we've really noticed here within Houston as well as the medical healthcare center for the US. Through automation, we're able to remove services and actions that healthcare providers or the care team needed to undertake, which is not really their focus area or their specialty. So automation, we see as a key driver there, being able to process data and provide insights. So that's automated reporting, automated image analysis. We see aspects such as transcribing. So we see the adoption of AI tools, which allows caregivers to have their conversations in exam rooms directly transcribed so that those notes are available, and it saves them time from having to process that data and instead being able to focus that on the care journey for patients. Thank
you. Another question here. How can you design for a future that you cannot predict?
Yeah, that's a good one. I had a little comic there on the first or second slide around innovation, and we can't we can't design for something that's been tested, because then it's not innovation anymore. The future is certainly unpredictable, so we cannot say that we are engineering or designing a future-proof building. Instead, what we can focus on is to create a future resilient building, and that future resilient building is one that is able to, that is flexible, so it can adopt, the spaces can be changed and altered to meet a different type of demand. It is a scalable architecture from a digital perspective, open protocols, data exchange, data tagging. So therefore, there's no single system, single proprietary system that's designed around. And when you have that digital scalability and digital flexibility, we are able to more quickly respond and help the building respond to external forces or external factors that require a change in the operations of the facility, and also then increase or leverage things like we see high bandwidth demand for image processing, for example. So that scalable architecture with a strong connection to the cloud allows either edge computing, it allows high performance computing, it allows data communication to external third parties within a compliance environment, obviously, but allows those third parties then to do to offer their services, which provides the outcomes to a future resilient and a future ready facility.
Fantastic, thank you. There's a question here about return on investment. The question goes like this: return on investment is particularly a stumbling block for securing funding for projects, both direct and indirect cost. Has progress been made in this area with your exemplar project?
We often hear of the 10x problem, where a lot of innovation is looked at, and they tend to, and it comes at a 10x cost versus what it would have, what the facility would have costed initially from a digital investment perspective, and that is a real risk if the technology and if the innovation that's being looked at is not mapped back to the key outcomes of that facility. So that's why it's essential to identify the stakeholders and identify the KPIs that drive their outcomes, whether it is the duration that for patient stay. So our facility had a specific cap on or design around the hours that we want to provide care to a patient, whether it is the turnaround of rooms from when a room is empty to, or when a patient vacates a room to when a room is ready to accept a new patient, whether it is the canteen's food processing capabilities, etc. So those key performance indicators tell us what is required for them to perform optimally. And then if there's technology that can enable and enhance and drive that process, then there's a direct return on investment for that technology. So there is a risk that we see on a lot of projects where technology is selected or digital objects are selected just for the sake of having a digital whiteboard, for the sake of having audio transcribing, for the sake of having camera analytics. But if those are not tied back to specific KPIs, then the ROI on those projects are not achievable.
Thank you. I will just take the last question. We have a few on AI. I will just select one. In your opinion, how close or how far are we from AI being a reality in healthcare?
I mentioned a couple of examples in the slides, as well as just as I've been answering these previous questions. So audio transcribing, we're seeing more and more being used. Image analysis, whether that's a variety of X-rays, MRIs, etc., being used. We see that private GPTs being set up, so natural language models that you can interface with, but based on a specific subset of data. So that's not public domain data, but that allows the caregiving team to interface with patient-like records and to use AI capabilities to provide a second opinion based on closed data sets. So those are just some of the examples that we see AI already being adopted. Data analytics for when biometric data is being captured. So we see that in the voice systems, we see that in the nurse call systems, we see that in the patient data systems, the audiovisual, just understanding how the spaces are being used. So we're definitely seeing that adoption of AI and automation in various sectors. I wouldn't go as far as saying it's putting anyone out of work. And I think what we should be focusing on, the adoption of AI really just allows people to do specific tasks to provide higher value and higher meaningful tasks, so that automated functions can be outsourced for the facility to be more operationally efficient.
Thank you. Thanks for a fantastic presentation, and thank you everyone for joining us today. You can still contact Jaco via the contact details that are shown on the screen. And we will wrap up the session. Thank you for joining us in the 2024 Snack and Learn webinars this year, and we hope to see you in our upcoming sessions. So thanks again. We will wrap up the session now.
Thank you.
Thank you.